Hello, welcome. I'm Bill Wake. We're here working on an old basic program that's an imitation of the commercial game Breakout, trademark somebody. Um, we got a little progress. I think the gameplay is kind of there, and we ran into some stuff around printing. It's not the focus of the app, but I thought, well, let's just go ahead and get it dealt with. And then once we fix that, we'll work on transliterating or translating this code um, well, from the transliterated version of BASIC, we transformed it to very odd looking Swift, and let's get it turned into normal Swift, and then see where we go from there. All right, so let's see the issue. The issue we have is there's different models of the old computer that we're working with, and basically, as I understand it anyway, the full video memory is from D000 to D7FF, and 32 by 64. There may, I don't know, that may be as big as it gets. Okay, but the one we're working with is 24 by 24. So notice it's not D00, it's D085. So a few rows down and a few columns over, it's kind of a chunk out of the middle. And that's what's creating the issue for our print. The original assumption with the memory was we could just get by with this 24 by 24. Anything past 54141 was kind of like out of range. But in reality, that screen memory always existed. It just didn't do anything visible. And so when we assumed the 24 by 24, our print statement went down to 54141 minus 24, I guess, and started printing on that bottom pink row. But the program actually pokes stuff down lower into like 56,000 or something like that, which it's allowed to do, but nobody will see it. So trying to make it so that we could allow for that extra memory, it messed up the printing that assumed that the screen was only going to be the visible area was all we would ever have to look at. I hate this part. Because we know the next time someone will have an app that uses the full 32 by 64 and like, are we going to be compatible and how's that going to work? Just craziness. Okay, let's see what we got. Well, if we have to do some searching, I'll find a search window. I thought this was going to run tests. It's got some build errors. Unable to process. Okay, that means it's got the wrong thing selected. What about this one? iPhone 12. Okay, let's run tests just to see where we are. And while it's catching up, we'll take a look at the print. And I think we left it in a messy state. It's not a great state to start with, but let's see if we can relate it. Okay, so we still have visible screen end at 54140. It's true that's the visible end. We added this notion separately of screen start and end that reflect this is D000 and D7DF that reflect the total screen. But I'm pretty sure some of our print stuff is messed up, and that's going to take a minute to find it. Let's go down to print. Okay. Peek, poke. Okay, here's print. All right, so we have our input string. We convert it to the characters to print. Now it's an array of uint8s. We did some work to try and get the screen consistently using uint8, and I think that's probably worth it. Let's see. So this, when we have the visible screen, it's in the center. There's stuff around the edges. I'm just shoving these tildes on the edges. So if I start seeing tildes on screen, I know I've got it off by one or something like that. Just a guard area, I guess you'd call it. And it's kind of an old trick. At some point, people started initializing their cells like hexadecimal DEAD BEEF, semi-random looking, but it's you'd see it printed out and go like, oh yeah. Okay. So what we're doing is we got this big loop here, around the body of it, and we're trying to peel off the visible length of the row. Okay, so the rows are 24 characters, so we're trying to peel 24 characters off of the characters to print. That's the screen line length. Okay. And yeah, so we pull those out of the characters to print. Then we're going to chop off the first visible row. So this is our scrolling. We're chopping off the first visible row, appending stuff to the end, and that should do the job. Okay, so and what we've done wrong is this is supposed to add things to the visible area, and I don't know where we're putting it. Okay. All right. So once you do that, you peel, we cut off the front of characters to print. So next time through the loop, if there's anything left, we're going to print it on a new line. Okay. And then I'm not sure what the cleanup down here is. We're going to print spaces to the end of, well, right now it's screen size, but it should be the end of the line. All right. And maybe we can do that more embedded in what we're doing. Okay. And how's things going on the testing front? Don't think our test started. Did I hit run before? I don't know. Now, I thought somewhere along the way, well, I have this problem. I'm bouncing between languages a lot. So, but I seem to remember that somebody had an iterator type thing that could walk through subsets of an array. And that's really what we would like to do with this partial thing. We're trying to get the front part of that line. It'd be nice if I could break it into segments and just grab subsets, slices basically. And maybe that's worth a search here. Let me see. Get a window over there for us. And like I said, I've been bouncing between these languages, so it's like, I think, somebody has it. Like, I don't know, could be Java or Kotlin or C# or whatever, but I know somebody had this concept. Right. So array slice, it's sort of it lets you specify a range of stuff on the array. Yeah, I don't really care about that. No, I'm after this iterator. I mean, it's great that they have slices, and that would make that simpler, but all right, let's see what's going on here. Okay, here we go. Print truncates output. What did it do? Print shift screen up. Okay, apparently that worked, at least as far as we tested. Print truncates the output. Okay, we tried to print anything we see. Here we can see what's going on. Screen count and original size. So we've done something that changed the size of the screen in the process of printing. On these 32, we got a space and another space. Okay. A print that needs line wrap, that's getting more complicated. And I think these are all spaces. Yeah, so something's quite right. And let's see. I'm going to maximize, or at least make this a little bigger here. Hide this. Okay. I don't think I even need this. But all right. So let's go to the example. Is that this? No. Well, I know there's a way to get this into its own zone. Editor. You think it'd be viewer window. Sorry, don't know. I can do it in Java. I know it can be done. Just all right. Is it this? Yes. Okay. Over here we want our tests. Over here our code. I'm just gonna maximize it. I'll try and watch my other screen if anybody's commenting. Okay. So print truncates output. I don't know what that means. Well, yeah, no, I don't think it's great. Printing it certainly should not change the screen size. That's a true thing. Okay, that's probably the thing we need to make sure is true. Okay, so what I want to do, remove first environment screen line distance. So that's saying chop off the front line. Okay, and screen line distance, that should be 32. Well, screen line distance 32. Okay, so if I go back to the picture, oh, there we are. Okay, so if you notice this 81 to 13, that's 32, 19 plus 13. So it's these rows are 32 apart at the same column, even though this is only 24 across. So there's 4 cells to the left on each side that aren't being, well, they're available as memory, but they're not available as visible stuff. Okay, so assuming we started here and we chop off 32, then our start is here and we're fine. Okay. I don't know if I'm, let's see. Let's go back to the code. Okay, so I think I like that phrase guard better. Let's rename it to guard area. Okay. So that's screen line distance minus line length. That's 8 characters of twiddles. Okay. We got our partial. I feel like that is correct. This seems correct to me. But where are we appending? I don't think that's correct. I think, well, I mean, it's appending, so it's adding it to the very bottom of the 32 by 64 range, and that's just not right. I think what we need to do, well, I think what will help if we I would like to change those cells. And I think what I can do, well, what I want to do, I'll just start doing it. Okay. This is for position. Let's see. How do I write this better? I guess I can do position ... less position. Oh no, this is, it's like screen visible screen start. Go back here. 53381 is this cell here, so this is where I'm going to start writing. Okay. Actually, I want visible screen end. So this is 54140. That's the next cell would be 54141. I definitely got screwed up thinking this was the address of the last cell, but it is not. Okay. 17 plus 24 is 54141, but this is plus 0 and this is plus 23. So 54140. Okay, so what I'd like to do is subtract my screen line distance plus 1. So I want to get back here. Okay, so let's do visible screen end. Take the visible screen end minus the environment dot dot screen line length plus 1. Okay, so this should be environment dot. I believe, yeah. Okay, so we're taking 54140 minus 24 is something 16. And then we're adding 1 to 54117. Okay. So I'm saying I want to start there. And what I want to do is go to visible screen end. Okay. So what's the problem? Result is unused. Well, it's because I haven't got there yet. For each. Okay, and let's call this position in. All right. Okay, so from the start of the row to the end of the row, int. This should be a range. Boy. Number less than value. Well, maybe I can do it differently. For position in. Does that work? All right, I'm going to look up. That's the other for each. There's one in Swift UI which does the UIs. Maybe it is this one. Okay, so you can say city in cities. Let's find a range. Oh, for number in range. Is that what I... I can put that in parentheses. Okay, now I'm going to put this in there. Okay, apparently I can't do something right. All right. So my theory is I should be able to go through here. I'm going to blank it out. Poke position. I know we have poke. Address value. Okay, and value. I'm just going to say 32 for now. We'll clean this up. Okay, so I'm trying to write blanks all at that position. Then I want to go let start. Well, I should do that up front. Let's start position. Let's take this. And hopefully it'll let us refactor, extract to a variable, start position. Okay. Going from start position to the screen end. Okay. So we're poking a space in. So we're clearing out that line. And then I'm going to repeat. I'm going to go for character in partial. Do something. Okay. And well, actually, I think I want the position in partial dot. Okay. So now we're going to write the characters. Poke position. Oops. Start position plus, this should probably be offset. Okay. What am I going to poke there? Well, I'm going to poke partial sub offset. Okay. So now I believe I've written the characters. I got to convert them to ints. I thought they were ints. uint8s. Is poke not take a uint8? Oh, I'm dreading the uint8 stuff. I'll let it cast it, but it's probably wrong. I'm pretty sure negative numbers will be treated incorrectly, so we'll get through this first. Okay. So in this case, I've written out 24 characters. I've written out 24 or fewer characters. And right now my screen is the full size minus the first line plus, what did I drop? Okay, I removed screen line distance. Okay, that's the 32. So I took out the first 32 characters. And I'm trying to point to the first one. Let's see if I'm doing it right. Okay, so if I put in a row of these, I ought to probably write my guardrail too. Do I have to do that? So now I'm appending that to the whole screen. So I'm writing in the middle, as it were, on the pink line at the bottom of the visible. Append the guard area, append the partial. Okay, we've done this. That seems like it might have been out of order before, because we're pointing. That's why I can't keep things straight, is why I'm confused, isn't it? All right, I believe we're starting here with the screen at 53381. We're deleting 32 characters, which means our screen start is actually, well, it's 0 as far as the screen variable is concerned, but, you know, it's what was 53413 should move up to 53381. All right. And what was below here should move up into here. And it could be junk. There's nothing stopping it. So that's why I overwrite with spaces. And then I print the stuff here. But since I chopped off 32 characters, I better put some more guard characters and another final 24 characters. Okay. We're getting there. All right. And I don't know. I feel like I'm arguing myself. But I think... well, shoot, I could fill that whole stuff, couldn't I? Would that be better? Might be. Maybe I should do screen line distance. Okay, so here's a different way of looking at it. So what I'm saying now is when I scroll up, let's get back here. Let's go to the big one. So 53381 is somewhere around, I don't know if you see my cursor, but I don't know if I can, nope, can't do anything. Well, somewhere under about the G, okay, down, and maybe 3 or 4 lines down, 3 lines down, I think. Okay, and then we got 24 rows, and then we're chopping off the front, and I'm not sure if we're still chopping off from here or from here. But the bottom then, if I chop off 32 characters, which is what I do, then the bottom is not there. That's 1 row short. I'm going to append 32 characters here. And that'll cover my 24, you know, be down here, but it'll cover my 4 over here, my 4 over here, and then my 24, and fill up the end of the buffer. Fill up the 32 characters I chopped off with guards. Now those guards, they may eventually scroll up, but they'll be covered with those spaces. So let's see. Okay. So I don't know. I'm feeling like I'm arguing my way around what's going on, but let's get. So what we want to do, I guess we will run the test again. I'm arguing it should be right now. And that means these tests should pass. Now, I'm not so sure about the top, if I've got that right, or if it matters. Apparently, something got better. Shift screen up. Print does not change screen size. Darn it. Okay. Somehow we got 16 characters too much. Okay. I don't know. Maybe I'd be better off starting over, but let's see what we got. Passing. Shift screen up is not happy. Can I see if we can see what's going on here? Okay. We poke something at screen start. Let's see where that is. Oops. Screen start, I think, is our 53381. It is not. Okay, so this should probably be visible screen start because we split out that concept. Okay, so let me change this. Visible screen start, you poke a character in the top visible area, poke something else one line down, and this should be visible screen end. Okay, then we do an empty print, which should just print a blank line. Okay, then we're going to check environment.visible screen start should now be 51. The letter in the top row should have been rolled off. Okay. Visible screen end should be that minus line distance. Okay, so visible screen end. Okay, so we poked something at the last character visible. It should now be up a row. Okay. Now the environment minus screen end, so I'm going to make this visible screen end minus screen line length. Okay, that's correct. Plus 1. So we should have written a blank and environment dot visible screen end should be a blank. Okay, let's try this test. I think that's more accurately what's supposed to go on. Before screen start, visible screen start were the exact same place. Okay, good, good, good. Now, how do we pick up 16? How many is this? 1, 2, 3, 4, 4. So that's 8. Okay. We get the environment. We get this screen count. We do a print. Now, I would say the only thing being appended let's see, let's find screen.append. Okay, we're appending our guard area. We're not doing our partial anymore. Oh, what's this? Right, I was writing out spaces before to make up for the rest of the line. If a partial line didn't reach all the way across, we put spaces. I'm not 100% sure that's the way BASIC goes, but it's probably a 95% case. All right, so what we did was we wrote a bunch of visible count to screen size. What's visible count? I think that's the 24 by 24. Yeah. And screen size. Okay, so we were filling out up to screen size. And what screen size? Well, I don't know. What is screen size? Oh, there it is. Visible screen end minus start plus 1. That's 24. Okay, well, let's check this one again. Oh no. Breakpoint. I don't see a breakpoint. I will continue. Okay. Let's try our tests. Maybe I bumped something. Who knows? No. Okay, now we can run them all. Woof. That felt very argumentative. I don't like being argumentative. I just want it to look obviously right. Okay. That to-do can go. I could definitely do this better. I could just poke the stuff. Let's do this way. So I just want to go from partial.count to visible screen end, yeah. Guess one more parenthesis there. I will poke start position plus offset. Okay, so if I wrote 0 characters, then I'm going to go from 0 up to the environment screen end. So I don't want start position. I just want visible line length, I guess. Meant dot visible dot screen line length. Okay, is that better? Dot less. Okay, so the count, I want to go from 0 up to 23 because I got a screen line of 24. Okay. If there were 2 characters written, they were in 0 and 1, so I want to do start position plus 2 up to that. All right. I think that's a little more clear. All right. I know we could do more to improve it, but if it passes, all right, good. So I believe we can. We'll come back. We're going to take a break, 2 or 3 minutes. We'll come back. We'll publish this, and this is a framework, a Swift Package Manager package that we import into our Breakout app, our Breakout clone app, I should say. You probably see the TM there somewhere. All right, so break package, drop it in, see if the game still plays. All right, see you in 2 or 3 minutes. Hi, welcome back. All right, so publishing this thing, let's commit it. So what we did was we made print work when screen memory is bigger than the visible screen. Okay. And it's encouraging that we only touched the environment code because that means we didn't have to do anything to the basic code. All right, let's go over here. We will tag this 0011. Create. And push. Include tags. All right, now I'll make this back. Okay, that's all provisioning profile stuff, but down here we will, I guess here we can update package. I should have done a little work on the README. My theory is put a little extra time in each time I'm around, but I didn't do that. Okay, but we'll let this thing build. All right, build failed. That's probably still thinking it's connected to the wrong. No? Okay, let's clean build. Oh, that looks like me having leaned on my keyboard, I guess. What else is different? That. All right, I think I can safely delete this junk. All right, now the diff. Took out some print that was in there. Okay. And run. So what I believe we'll get is the game running, and then we're ready to try and manipulate this thing into position. While that's building, let's go back here, and I'm going to pull up the code. Okay, so what we've done is we've transliterated each statement into Swift. If it's a for next, well, like the one in 55, that's just a delay loop. We just translated that to a delay. The one in 20, we could see what was going on. I don't know if we left any for loops or not, but if we had for loops, we would translate them into some code. Go sub keeps a stack and does returns. There's a return statement, and it takes care of that. And then peek and poke and all those things. And if it's a variable reference, we just did a Swift variable, and it should be there. All right. So what we're going to do is I've made these annotations on here. So I'm trying to do an analysis to say, like, where do you go to and where do you come from? So line 40 comes from line 60 because there's a go to there. It also comes from, I should put that in, but because there's an intermediate go, colon in there, it says put both lines. Well, whatever, I probably called it minus 41 comes from 40, because it was preceded by that. So what I want to do is turn anything that's not a target of a return statement or go to or next clause should just do a fall through and make sure we've done that correctly. Okay. I think we'll probably be running by now. Okay, yes, we are. Okay, so we go. It printed hello blocked. That's good. Something is off. Okay, we can't see our... Oh. Yeah, we are... Okay, so something's funny with the visible. This should be much more over here. We should be able to see both edges. I don't know what's going on, so we'll have to dig in. Story of the game here. Okay, so what's going on at some level is this content view is the main view of the thing. It's got a little helper method to turn OSI character set into the one we're using here. I probably should comment those, but I think that's a block and that's a ball. And then it draws things. Okay. So it's going from 0 to 23. And screen no longer starts at 0. So we're seeing it shifted over the amount of, I mean, I think it's 3 lines down, and I don't know, must be 8 or 16 columns, I think, if I counted right. And so when this gets environment screen row, it is starting screen at the true start from the machine's perspective, I think. All right, let's go back to this. Let's see what we say is going on. Okay, so screen start 53248. Where's screen? Where's the actual screen? Must be in... Well, there's that. Definition. Oh, it was there. Okay. So it's screen end minus screen start. Okay. Well, that's not visible. That's the big one. Okay. Maybe I need something called visible. Or maybe I should make this thing aware of where it's drawing. So that's really like visible screen start minus screen start, I think, right? How far is it? Or +1? Now, do I want to do that in the content? Let's try it. I'm gonna let... And again, I don't know if this is... Okay. Let's take offset plus. What we'll see, if it's wrong, we'll definitely see something. Well, we may get a crash because it's off by 1, but we will probably see either a side wall not written, or we'll see a tilde or something. Just wait a minute here. That seems stuck. Okay. Oh no. Okay. Oh, really? Okay, I'm going to do it the stupid way. Let's see if it works, and then so 48 2 is 50, 32, 33. All right, let's see what's going on. Okay, yeah, see, sidewall is there, so I am off by 1. Okay. Yeah, it's better. Do I see my paddle? Not yet. Okay. Huh. Breakpoint. Okay, let's turn that off. Continue. I think maybe a little to the left. Notice it keeps going. Also notice that bounce is a little funny. And you can probably tell there's 2 ticks of the paddle for every tick of the ball. Yeah, just fit. Okay. Well, usually I die before this. Should hit the wall and stop. That's a good thing to check. All right. And I think, yeah, it's going to miss. All right, we'll let it fail. Okay, we did not get score before. Okay, so this is progress, believe it or not. That's pretty ugly, but that's the way it was. Okay. Wowzers. So I think we're finally ready to check our fall throughs and all that stuff. Okay, so what we're doing is basically we're trying to make sure the semantics, like the basic semantics, say one statement falls through to the next. Okay, and so I've got some of them here, and what I want to compare is, okay, let's see. All right, in the code here, like you can see 15, well, the first target of a go-to is 40. Okay, so all this code can be folded together. There's no problem with it. It's all just going to be fall through, and nobody ever gets in the middle. Now this is different because I can't include 40 in that because I still need a target for my go-to. All right, and let's see. So I mean, the question in my mind is, I would like to make some sort of quick, easy characterization test or pin down test. And if you're not familiar with the term, a pin down test, the idea is we just take whatever input, take some input, whatever the system does as output, that's what the system does. And therefore we'll record that and make sure next time it does the same thing. So I think, let's see, let's find the score. Okay. At this point, it says go to 0. Okay. Let's see, what am I going to do? I'm going to try and make a test. All right. And I haven't done this in the basic setup yet. So, how can I... The thing is, like, this runs as an independent program, so I'm not going to try and move the paddle. I'm just going to catch the final picture if we do nothing. And it will not be sophisticated, but we'll catch the most basic kind of problems. Okay. Let me try that. Now, I won't bother with their setup or teardown. And Control-A. Yep. Okay. I'm just gonna make one. Let's call it Pindown 1. Pindown start. No moves. Okay. So my plan is, let's see. We're gonna call. Well, somehow I'm going to take a snapshot. I'm not going to pull in, there's a nice package Luell and Falco put together, approval tests. I'm not going to pull that in. I'm going to do it the cheapo way. What I want to do is I want to take a snapshot of screen. Okay. Okay. Let's run this thing. We're going to run the app. Let it end. Okay. Then I'm going to take a snapshot of the screen and I'm going to compare to a previous snapshot. All right. And let's see, how can I do that? You know what I'm going to do? I'm going to add to the screen. Let's see. My theory, whatever I bumped, Command High finally came up. My theory is, what if the simulator gave you a function that would look at the screen and give you a cryptographic key of its contents? Now, I have no idea how to do this, but cryptographic keys, you feed in some stuff and it encrypts it. Well, cryptographic key is just going to kind of make a signature of your thing. So let's see what we can do. So the idea is I will get a screen. I'll take the screenshot the first time, run it. I'll assert that it equals 0 or some random number. And then see what the actual value is, change it, and leave that as the snapshot from then on. Okay. Let's see. Swift cryptographic hash. And sometimes they call it fingerprints, but yeah, SHA hash. Can I do something? Okay, if I've got a hash, you need to convert it to a data UTF-8. Okay, and you call hash of data. Okay, we're not trying to prevent our company from being bankrupted by shopping hacks or anything, so we'll just take 256 is easy enough. Okay. Let's, if you want to get the string of your hash, for the textual representation of the hash. Get the string of your hash, convert it using string format, %02. I guess it could have leading zeros. We won't really care. Okay. Once again, hacking with Swift for the win. Yeah, Paul Hudson, he has so many great articles on this site, and I saw he just had a big conference and doing great stuff. All right, so what we're going to do is I think we already have a UTF-8, whatever that creates, an array probably, and we'll call hash on it. Okay, so kind of like that. There we go. Okay, we'll probably have to import CryptoKit, but it'll tell us that, I assume. All right. What is this called? Let's call it screen fingerprint. All right. Let's screen fingerprint of type, I don't know, what is hash.description? Probably maybe a string. Okay, and must have access or specified. Yes. Well, let's just return wrong for now. Let cannot be computed, replaced with var. Okay. Okay. I guess I could test drive this theoretically. Environment test.swift. Fingerprint. Okay. Get an environment. Let hash1 equal environment.screen fingerprint. I left it like that. All right, we'll get the same one. We will do a print. Just change the fingerprint. We will get hash3. All right, and now we'll do some asserts. First two should be equal. And these two should be different. Okay. All right. So I'm saying I'm making a fingerprint of the screen. Not sure what the problem is, but that's okay. Start the initial screen, create a fingerprint twice, and change the screen, create a new fingerprint. Okay. Let's run it. I'm hoping it just builds once it realizes what's going on. Yeah. And this test will fail. All right. So, yeah, this should be not equal. We're just returning a constant. Okay. Let's take this. Data of input data. Okay, and I think our screen is the right type. I'm hoping an array of uint8s is what the data class wants. Data of screen and return hashed.description. And why aren't you complaining? There we go. And I believe that was CryptoKit. Everybody happy? Okay. And now my hope is it works. Yay. Okay. Commit. Add screen fingerprint. All right. We'll tag this. Create. And push. Let's see, what have we got here? Are we, how, oh, we have no test, so we're creating a test. Okay, I guess that's all right. We don't have any contents. We did make a change though, so let me push this to this. Yeah, I'll break my rule and call it to do. I try not to leave them. Okay, that's fine. Let's commit this. Commit. All right, so we adjusted content view based on expanded screen output. I don't know, a little cryptic, but all right, now let's update this. Oh, I still didn't edit anything there. Okay. Yeah. All right, let's go to our test. Okay. We need this. All right, so we're going to create a new blocked instance. We got to feed it some stuff. Okay, we got to give it an environment. All right, so we'll create a new environment. Okay. And we'll let game equal blocked of env. Okay. Now we do game dot, does it run? Game dot run. Okay. And that hopefully returns eventually. If we got an infinite loop, it would not return, but eventually it gets down here. Does it go to 0? The code in the basic support says go to 0. That must mean stop. All right, and it stops, and the basic interpreter called here then returns, and run returns. So run is the right place to go. What's our import? Basically, yeah. Okay. Now we're going to call game.run. All right, and that's kind of the thing we're doing. We're going to take a snapshot, which is going to be a fingerprint. Let fingerprint equal env dot screen fingerprint that I didn't make public. And assert equals fingerprint and the golden version, we can call it. Run the app, let it end. Yes. Snapshot. Yes. Compare. Okay. All right. Back over here. Public. Everything you want visible definitely has to be public when you put in the packages. So, see, you'll notice our things we let the user manipulate. Yes. Functions. Yes. Okay. And this time I'm going to touch that README. Oh, I realize I've not been keeping my to-do up to date at all. Fix print. Yes, we've done that. Today. Is this for, yeah, 806. Fix the print to print the visible area, not the end of screen memory. Is it needed? Yes. I guess I can keep these dashes. Is it needed? Yes. Add stop end statement. Well, okay. Make error public. Yeah. Accommodate blocked as a switch statement method. I don't think this applies anymore. We got rid of the line in out stuff. Okay, this is what we want to do. And actually, we're doing a Pindown test. Start, no moves. All right, is that more accurate? Okay. Now, over here in blocked land, let's touch the README. Okay, we can at least mention the fingerprint. Okay, so screen fingerprint yields a string, a cryptographic hash of the current screen contents. Good. What else we got? We'll just do environment. Work on environment. Okay. Anything public. Yeah, I don't think we. Those are not. Okay. Keyboard simulated. Keyboard poke. I guess we'll alphabetize. This is kind of like the next column. No, it's the rows to read next time the keyboard is scanned. And keyboard, what was the other? Simulated. I guess this is an int. Maybe I should say it he's really a UND8. Okay. The rows to read next time it's scanned. Keyboard simulated is uint8. Rows uint8. Columns, it's a pair. And it's the, well, this is which rows to read next time it's scanned. The values to be returned when keyboard is scanned. Okay, so there's a poke like 57088. You push that in, that gives you the bits that represent which rows of the keyboard matrix should be scanned, and then keyboard simulated tells you the values to return. So we don't have a keyboard, but the old apps were written with one, so you got to do something. All right, this is an improvement. I will accept it as a step forward. Okay, commit. Make a screen fingerprint public. Update README. It gets a little old doing these things. Okay, push. Include tags. I wish it would leave it on because I already set that. Of course, if it did, I would probably complain that it, never prompted me or something. So update our package to 13. Now, one thing that's interesting about this is we are running headless. The content view is not going to be involved. We've only got the environment, the basic support in our program. So it should run moderately quickly. There is some delay loops in there to make the program run at a speed you could actually play. Let's see how this goes. There it goes. Okay. Now, clearly, that thing is not going to return golden version. It's going to return some 40-character hash, probably. And you can imagine, writing all the stuff. We hope. Okay. I don't know why it says it's still testing when it actually finished the test. But it passed. Oh, that should be assert equal. Okay. Seemed like a very unlikely cryptographic hash. And I want a failing test here. I might want to get the fingerprint before and after. I don't know if it's legit. Okay, that's more like it. Can I select this? Yes. Okay. So we got our failing test, we got our hash, and I think we're on track. Okay, so we'll come back. We'll take a break. We'll come back in 2 or 3 minutes again, and we will apply this thing and start doing some refactoring. All right, see you in a couple minutes. Welcome back. All right. So I see what's going on over here. The reason the test we're running is we have a UI test. I don't want it. Let's at least take it out of the test configuration. I don't know if I can just delete it. I've got to do it in the files. All right. So I'm going to take this out. Then I got to take it out of the project here. Remove this. Okay. All right. And blocked. I believe I cut this. No, it did not. Okay, great. All right, now this time we run it. It should be the same because we're doing exactly the same. We're drawing all the blocks and the side walls and top and all that, and the ball's going but don't bounce and go too far and die. All right, so let's run this, and it should pass. Yeah, and if I run it again, it should pass. And it's taken a while because it's not a UI test per se, but it kind of is, right? I mean, it's not a UI test, but it's got the delays in it. Now, it'd be nice if we could speed that up, and that's probably a refinement to make on the environment to let you control that delay loop. But in any case, I think we have a bit of a Pindown test. Let's just make sure we can break it. Okay, so something we know happens at the end is the score. And I think it would look better if it had 3 spaces in front of it. Okay. The way it was right under the sidewall. Okay, so I'm going to print the score. I'm going to change the way this prints. I'm going to run my test, and it should fail. If it doesn't, we've messed something up. Usually I should say I've messed something up. I try and give you all the credit when it's working right, the comments and well wishes sent across the universe. But yeah, when it fails, it should just be on me. Okay, this should fail. Yes. All right. And what did it get? It came back C6B instead of 050. Okay. Now I'm actually gonna leave that change. So this is what happens if you change it, and this is why Pindown tests that go through the UI, they're notoriously prone to this. You change a little bit of stuff in the UI, and all these tests start breaking. And in this case, we're just taking that final screenshot, but anything we do that changes that final screenshot is going to change the fingerprint. And so with UI tests, they have a very similar characteristic. Any little change, like the spaces I just added, it's going to break any test that relied on that screen. And, you have to go through and manually check them all again. Oof. All right. But for us, this will be our new version. I'm making a functional change. It's kind of a weird way to assert it, but we weren't asserting anything on score anyway. All All right, should pass. And then I'm going to do another one. We're going to set the paddle moving to the right, and let's see, is that going to change anything? I mean, it'll change the final screen because the paddle will be on the other side. I don't know. Will it be interesting? Maybe not. Well, it will be interesting because it proves that the paddle does something. Moving the paddle does change something. Did that run? What did we get? C6B. Oh, is this not going to work? C6B. Oh, that is different. It's not equal to 050. Okay. I think that was the same. C6B. Let's run this twice. I mean, this is a relatively fragile approach, I grant you. And here I am paying that price already 5 minutes in. Okay, and one more just to make sure, but I just copied it, so it should be all right. Okay. All right, so we created a Pindown test. All right, now let's get some refactoring going. Okay, so these fall throughs. All right, so there's no point in, I don't need to do the fall through and then come back through around the loop and do a case 15. Same thing here, this and case 20. All right, and same thing here, go sub 30, go to 30, go in line 30. Okay, now this one, go sub says go sub 305, and then we added some compiler information. Hey, return to line 40. All right, so that makes this a target of a go-to. Let's see if I can make that visible here. Okay, so 30 is okay, but 40 is the target of the return statement of the go-to go sub 305. Okay. What else we got going on here? Okay, 110 to 110 to 205 to this, back to 40. Okay. 110 to 110. Okay, yeah, there's that go sub returning to minus 41, which is sort of the halfway point of this line. And that thing says go sub and return to line 50. Unfortunately, because of the way the return statement works, we have to keep that case. Okay, go sub 205 returns to line 55. It does a delay and falls through. Okay, let's run our test. So this is somewhat like in a compiler, they have the notion of basic blocks, and it's usually sort of the maximal block that has one entrance and one exit. We're doing the ones, we're taking blocks with one entrance and potentially multiple exits. I think just the way basic works, that tends to be more convenient for what this fall through stuff does. Okay, our test succeeded. Let's keep going. All right, now 110. That's here. Okay. This is our keyboard reading stuff. Poke 530 turns off basics control C handling. Poking this says I want to set row 4. All right. I think maybe we should add that extra test before I change this area. Let's skip this area for now. Let's find the next one. Here's 150 return. Okay, somebody did a go sub 205. All right, so poke the ball, and let's look at our code down near 205. Get full size here. Okay, 205. Poke the ball. Comes from line 50. That's the call. All right, and then it falls through to 210. And here you can see one of these. It'll be an exit to 225. But we can just keep falling through. Yeah. Okay, up to 225. Needs a target. 225 is a target, I should say. Okay, so 205 falls through here. And, you know, I'm going to be a little careful in this one. All right, if peak, go to this, otherwise go to 205. Well, because each one ends with a go to, we have to let the basic have its say. All right, so we can't get rid of that one. But this one, we can. We fall through, and case 220, it does some stuff, but it doesn't do any go-tos. Okay, so we'll fall through there. And case 225. Sorry, that was 220 and 225. Let's go over there. 220 peak, fall through here. Oh, 225 has to be a target. Okay, so cancel that one. The fall through is okay. All right, so we're getting the low hanging fruit, I guess you'd say. Okay, so 230, this can't do it. This one can. We're checking 230 through 245. Okay, so this one can be a target. And so we don't need 240. And again, it's not doing a go-to, so its fall through is okay. Okay, 250. If the ball is way out of range, go to 900, else 225. Okay. 255 and does a return. All right. And then this is another go sub 305. Let's go look at that. I have to do the view thing. Okay, 305. All right, this is the 305 down to 365 realistically is the code that draws the lines on top and on the sides and all that. It's called one time, and it looks like everything can fall through down to the return. Okay, there's no ifs. The for loops we've already handled. Okay, let's see. So 305 can be a lot of fall throughs. Okay. And then maybe before we go to 305, let's just run our test one more time. Not the last time. We're going to run it a lot. And while that's running, I'm curious where delay is used in environment here. We have this delay field. Is that just for, whoops. Delay factor uses it. Okay, so the delay statement. I thought there was something. Okay, there we go. I think there's something that causes delay at memory accesses maybe or something. I believe there's something somewhere. Okay. Fall through. 310. Falls through to 320. Yeah. Okay. Falls through to 345. Nobody referenced that, do they? Nope, nope, nope. S falls through to 350. Notice this whole block of code we did up to the return, so that's all right. That. Okay. Yeah. And again, I'll just run. Okay, so this is the screen setup code. Then we have 370. Let's do a search for this. Find, whoops. $370, go. It's not referenced anywhere. Okay, so my claim is nobody's using it. Okay. Now 375. Let's take a look there. It's there, and back around. Okay, so this is also dead code in the original. Okay, and I'm sure what happened, this for next got turned into one line. Next return, it probably used to be next Y return, and somebody folded them together. You might do that to save a little space and maybe run a hair faster, but you kind of cost your space when you didn't take out the old code. Okay, ran, all right. And let's do this one, 900. We're going to fall through. Somebody jumps to 900, but nobody jumps to 905. All right, and I could go through and find the cases for that and search for the number and all that stuff. All right. So what I'm trying to do is get the implicit go-tos where they implicitly can fall through. We're trying to get those cleaned out, and this should pass. And we will clean up. I'm going to leave the basic code for a while, but I will delete these fall throughs that we commented out and the cases we commented out. Right. Test succeeded. Very good. All right. So that 15 comment. Case 40 we target. 41 we use. Go sub. Break, yep. Okay, here's, oh, that's go to 40. Okay, I guess those didn't have much of that. Fall through. Oh, we didn't do the keyboard one, yeah. Okay, we did do this. So this fall through can go, the case can go. The break is there, the fall through goes. So at this point, these are useless comments. Let's get them out of here. I'm keeping the old basic code, but not this. I'll take this dead code out. Okay. We'll run a test. And I think what I want to do is add another test if I can figure out how to simulate it. All right. So what I want to simulate is you hit a right arrow. All right. And the code we execute in that case, which says hit the right arrow and hold it down until you see a down arrow. Okay. But this code is the code that is going to be present. Okay. So blocked tests. Okay, we'll do it that way. Okay, so somewhere I'm going to paste this. All right, we'll need the environment. We'll keep all this stuff for now. All right, let's move this row up. Okay, and this is going to be another test pin down. Move hard right. Okay. And Control I. Okay. This better be different. All right. Let's run them. All right. I'll try and be useful while that goes. Let's see where the pokes go. Is it poke or peak that delays? And maybe nothing is at this point, but let's see. We gotta sleep. Okay, it's gotta be in the basic support. No. That's running far slower than I would expect if there's no delays. All right, let's do the global. Sleep and package ignoring case. Yes, sounds good. Delay. Environment. Interesting. Okay. Well, it's slower than I thought. This test should pass and this one should fail. All right, it got 246. That should be the one with our paddle on the hard right. Okay, and now this test should pass. Okay, come on. No moves. All right. So I feel more comfortable modifying that loop. We didn't test everything by any stretch, but at least we've tested something. So I'm going to be more comfortable modifying the 110 loop. Okay, so we poke, peek, and fall through to line 120 with this case. Same thing. There's again, I'm going to check the code. 110, everything is just falling through up until you get to the return. There is an if, but it's an inline statement. Okay. So fall through case, fall through case. Fall through and return. Okay. I haven't decided if the separation of environment and basic is helpful or hurtful, but when we finish refactoring, the environment calls can be there, the basic call should not. So I kind of think maybe it's a good choice. And I'm going to start deleting those comments because I'm pretty sure the test will pass. There it goes. Once we've dealt with these blocks, we can start, well, we're on this path to making a structured program, I guess you'd say. You know, it's got nested ifs and whiles and stuff like that. It could have subroutines. But Okay, after the break. Yes. All right. Assuming this passes, we'll commit it. I don't know if you've ever had to refactor, well, basic code or assembly code. You go through stuff like this. It's progressively harder the lower level language to make sure everything is, nothing is a weird target or anything like that. I mean, assembly has, you can call indirectly through a variable to get the address and things like that. So it's not very visible what's going on. You have to really, really do some work to decode it. Okay, that's all good. So we added a pin down for moving hard right, and we removed unneeded fall through. Okay. All right, and I would say we just got rid of, I don't know, a third of that mechanism stuff. All right. So what I'm going to do is look for stuff that I'm trying to get things so everything's an if statement, if else, and not like if else contents. Let me find one that's not. Okay. Well, this one a little bit. Okay. This one is already structured in the sense that it checks an if and it does something. No jumping. It checks an if, does something. No jumping. So this whole return routine I think is pretty good. All right. So as this is I'm about ready to dump the basic code here. I think it will be just as clear in Swift as it is in basic. Hopefully more clear, but let's stick with that. Okay. So let's take care of this routine. Now, another thing we can do, what is this thing doing? Well, this is basically moving the paddle, and we've made progress understanding that. So one thing I can do is I could define a variable move paddle. I think it will let me do this. Let's try static let move paddle equal 110. I don't think I need the static. Okay, let's see if that's acceptable. Yes. Okay. Cool. All right, so I'm kind of giving things a name, but like I said, I trust this code enough that I think it will be just as readable in Swift. And getting rid of this will improve the look. Okay, and so this routine is very good that way. It you call it, it does a bunch of stuff. It doesn't jump outside or do anything else, and it's all ifs and elses until you hit the return statement. That's a good step forward. Okay, let's see. So the next one, this is getting messier. All right, the one I know I want to get rid of, let me jump down. Just a couple minutes left. I can see 900 is only the target of one call. Let's get down there. Okay, so I'm jumping down. Here's 900. It comes from 250, but notice nobody else is calling 900. So that means instead of calling 900 in line 250, I could just do what 900 does till it's done. All right, and that's what we'll do. So I'm kind of folding in these branches when I can. So if you called that, well, we can certainly move these things closer, right? Because they're independent cases right now. Okay, here's this. If V goes this, then 900. All right. Okay, so what I'm doing is I'm kind of tracking through the flow. If I did basic GOTO 900, it does a poke, and I'll just pull that up. Okay, I'm going to say instead of doing basic GOTO 900, I can do a poke, a print, and an end, which could be nicer, but okay. That code is referenced nowhere else. Now it's all inside the if statement, and I can get rid of this jumping around. Okay, and I don't think I need this anymore. So if B is greater than 54141, whatever that means, poke a blank where the ball is, print the score, and end the program. Okay. Now 255. Let's see if it's a target of anything else. I don't think it is, but we'll check. 255. It falls through from here, from 250, and it jumps back to 55. So we can do the same trick, all right? I can say if you were to go to 255, all that would be happening is you would do a return. And I'm leaving both branches of the if are doing a GOTO. I mean, return is some stack manipulation in a GOTO, but it's implicitly there. Okay, so I think this is fine. Now, I don't know, can we give this a name? I think this is move ball. Started at 205. Okay. I'm going to call this move ball. So I'm using the fact that I can name these things. It's the old basics certainly didn't have labels that let you put names in them, but I'm faking my way around it, I guess. It's 205 is move ball, right? 205. Okay. And then I guess let's find 205. Okay. This can be moved ball. It's the only call. All right. Let's find 110. Go sub 110. Well, this is move paddle. Okay, any more 110s? Okay. Well, we'll run those tests one last time. But that's a good start for the day. So we fixed the print issue. We added a couple of Pindown tests. We went through and dealt with the implicit GOTOs that fallthrough represents. And we started pulling this thing into a more structured program. And so every time we can, turn something that's not, something that calls the basic stuff into just straight code, properly nested, all that, then we're doing well. Okay. And the tests are green, and we'll call it a wrap there. Next time will be Sunday afternoon. Let's see, 7th, 8th, Sunday the 8th, and 1 to 3 p.m. Eastern time. And I hope you can join me then. We will continue refactoring. We will have most of the control flow dealt with, and I think we can finish dealing with the control flow and then maybe do some more cleanup. So I hope I can see you then or some other time. Take care. Bye-bye.